It was Stephen Hawking who first pointed out that black holes behave in such a way that they contradict each other with two fundamental theories, relativity and quantum mechanics. This paradox has puzzled scientists for half a century and has led some to question the fundamental laws of physics. Scientists have recently announced that they have solved this problem based on the fact that black holes have a property they call quantum hairs of gravity. This would be a huge breakthrough in theoretical physics. So what is the secret of discovering and solving Hawking's paradox? I will talk about it in this video. Fasten seatbelts. Subscribe to the channel, like it, because I tried very hard on the program of this amazing tour. Let's fly! What is the black hole paradox? In astrophysics, a black hole is defined as an object so compact that the force of its gravitational field prevents any form of matter or radiation from escaping. That is, their gravity warps space-time so much that nothing can reach the speed needed to escape. Such objects cannot emit and scatter light, which is why they are black, which in astrophysics means that they are optically invisible. Similarly, information cannot exit it, and Einstein's general theory of relativity suggests that information about what enters a black hole therefore cannot leave it. That is, say that we cannot determine what a posteriori entered into a black hole. But quantum mechanics says this is impossible. Stephen Hawking drew attention to this informational paradox. New discovery. Physicists have been shocked by new research that could drastically change our understanding of black holes and provide a solution to a problem that has puzzled scientists for half a century. Hawking realized that black holes radiate in a unique way. Their distortion of space-time will change the wave nature of the surrounding quantum fields so that a form of thermal radiation will arise. This means that the black hole must slowly evaporate, radiating its energy photon after photon straight into the universe. As it radiates, the black hole loses energy and hence mass. Just think. Information can in principle disappear into a black hole as a result of its evaporation. Conversely, the laws of quantum physics state that information is stored in black holes. The whole secret lies in this informational paradox. Scientists have been wrestling with the riddle, proposing many hypotheses with an incredible number of solutions, including the firewall theory. The wall of fire is a theory where information was supposed to burn out before falling into a black hole. Also, scientists put forward another interesting theory in which it was assumed that black holes have fuzzy boundaries. This is the Darkino's fuzzy ball theory. Do you know what is the most interesting? Most of these proposals required a rewrite of the laws of quantum mechanics of Einstein's theory of gravity. And these are, for a second, the main pillars of modern physics. All information conservation theories actually describe these remaining connections to the universe as hair. This is why some scientists believe that when matter collapses into a black hole, it leaves a faint imprint in its gravitational field. The authors call this the quantum hair of gravity, because their theory replaces an earlier idea. The authors call this the quantum hair of gravity, because their theory replaces an earlier idea called the no-hair theorem developed in the 1960s. This bold black hole theory, based on classical physics, claims that black holes can be seen as surprisingly simple objects, defined only by their mass, electric charge, and angular momentum, which is related to their speed of rotation. Scientists claim that black holes are much more complicated. They believe that their quantum hair theory provides the mechanism by which information is preserved during the collapse of a black hole. This new solution applies quantum thinking to gravity in the form of theoretical particles called gravitons. These hypothetical elementary particles will transmit gravity in most quantum gravity systems, similar how to photon is associated with an electromagnetic force. Through a series of logical steps showing how gravitons can behave under certain energy conditions, the team demonstrated their model of how information inside a black hole can remain connected to the surrounding space. More precisely, the researchers compared the gravitational fields of two stars with the same total mass and radius but different compositions. It is important to note that in classical physics, two stars have the same gravitational potential, but at the quantum level, the potential depends on the composition of the star. When stars collapse into black holes, their gravitational fields retain the memory of the star's composition and lead to the conclusion that black holes have hair. Information about the matter that fell into the black hole will leave a trace of its passage, which theoretically gives us access to the composition of the black hole. Professor Xavier Calmet thinks the problem is solved. This solution does not require any speculative ideas, because the study shows that both theories can be used to consistently calculate black holes and explain how information is stored without the need to create radically new physics. But as always, there is one big but. There is no obvious way to test the theory with astronomical observations, as gravitational fluctuations would be too small to measure. As a theory, it is interesting, based on a solid foundation, but it must be carefully studied by the scientific community. Do you agree? Scientists still rightly concluded that it will take time for people to accept it. One consequence of Hawking's paradox was that general relativity and quantum mechanics are incompatible. And the new discovery just says the opposite. They are quite compatible. So it will take time for people to accept the fact that a radical solution is not required to solve the problem. Friends, join our community of fans of science and technology. What is? Links can be found in the description of this video. Hugs.